Well, good morning, everybody. We are looking right now at the next section of our Topic 11 notes. It is talking about arc length. And here's our essential question. If you're one of those people taking the notes and you need an essential question, how do I find the length of an arc? Okay, so if you're not familiar with what an arc is, I'm going to encourage you to go back to the video where we talked about all of the vocabulary words for topic 11. It will be linked in the description right down there. So if you're missing any of the vocabulary words, go back and watch probably about the second half of that video where we talk about the table on the vocabulary page, the table on the bottom of the page. Okay, the table of words on the bottom of the page. So go ahead and get that done before you continue on, and then come on back to this video where we're going to be talking about arc length. This right here. Okay, so if you're filling in the blanks on here, arc length is a fraction of the circumference. Okay, so just as a quick reminder, an arc is a piece of a circle, it's part of a circle or part of a curve. So when we talk about an arc and you think about a circle in terms of a pizza, an arc is the crust of one piece of pizza. Okay. And actually, here in a second, we're going to have a practice problem that uses that exact analogy. Okay. So the arc length is how long is that piece of crust. Okay. So when we talk about measure of the arc, most of the time that's going to be referring to measure of the central angle. Okay. It all has to do with the measure of the central angle, theta. Now, y'all remember that symbol theta from back when we talked about trigonometry. We talked about how most of the time the symbol that they give you for an angle is that little Greek letter theta. It looks like a zero wearing a belt right across the middle. Okay, so that is theta, and that's how we're going to mark what our angle is. The central angle, of course, being an angle that's inside of the circle. The point in the middle of that angle is the center of the circle. All right. So the next thing that you're going to be putting on your page, I want you to go ahead and fill in these reminder spots. Okay, the thing that's highlighted in this first little picture, that is an arc. The thing that's highlighted right here, that is a semicircle. Okay, it is half of a circle, so you could also call it a semicircle. Now, something important to remember right here is that on a semicircle, the angle that's inside of half of a circle would be 180 degrees. A full circle would be 360 degrees. We're going to talk about that here in a second. This last part right here, this picture right here is highlighting an example of a central angle. All right, so that's our reminders. That's what you'll need to fill in on that part of your page. The fraction of the circumference, that's what you fill in up at the top. The next thing on there is the circumference itself. Now, this is a formula that we have used in just about every lesson up until now. In topic 11, we're going to continue using it after this too. The circumference, 2 times pi times the radius. Okay, 2 times pi times the radius. That's what we're going to be using for this. And you've got to remember that the circumference, that represents the distance all the way around an entire circle. Okay, so an arc length is really just a piece of that. Okay, a fraction of the circumference. An arc length is just part of 2 pi r. And so this part right here, this 2 pi r, that's going to end up being part of our formula when we figure out the length of an arc. Okay, the other thing, the circumference is one of the things we need to know for this formula. And the other thing is this, it is a central angle fraction. Now, what I mean by that is when you look at this angle, you can tell that this angle does not represent one full rotation. As we talked about in the previous lesson, one full rotation is 360 degrees. Well, this right here, this angle theta, only represents part of that, a fraction of that. So what we do, what we call the central angle fraction, is whatever that measure is, theta, divided by 360 degrees. Okay, so that gives us what fraction of a full revolution, what fraction of a full rotation is this angle right here. And what we do is we take that fraction, whatever fraction out of 360, and we multiply it times the circumference. The idea here is that the proportion of this angle to 360 is the exact same proportion of this arc length compared to all the way around the full circumference. Okay, so we take that central angle fraction and we take the circumference and we multiply them together, and that gives us the length of this arc. That gives us the length of this piece of the circle. All right, so let's do some examples that use this formula right here. First example is this. What is the length of arc BC? Okay, arc BC obviously is going to be this part that I'm about to highlight. It's obviously, it's exactly what the name sounds like. It's the arc in between points B and C, going straight around there, right there. You can see that the angle that it gives us is 135. You can see that the radius on this circle is 6 feet. So if we're finding the circumference, okay. Actually, before we get too ahead of ourselves, I want you to go ahead and write down 3 steps to solve a problem like this. Step number 1. Go ahead and write down these 3 steps. Step number 1 is find the circumference. Step number 2 is find the central angle fraction. And step number 3, we're going to multiply those 2 numbers together. Okay, it's a very simple process, and you're going to see it as we go along how simple it really can be. Okay, this is the third lesson in a row where really all we're doing for these problems is applying the formula. Okay, so first we find the circumference. Well, we already know what the circumference is. It's 2 times pi times r, and we know what r is. R is 6. So if we're multiplying all that, it's 2 times pi times 6. Well, that's the same thing as 12 pi. Now remember, if we were doing a circumference type of problem, if this was the question we were trying to answer, 12 pi could be a good answer all by itself. All right? That's something you could type in the calculator, or you could just leave it as 12 pi. Either way, that's what the circumference is. Okay? This is the circumference of that circle. So that's step number 1. Step number 2 is to find this piece right here. Our central angle theta is 135. 135, you already know, is not the same as 360. 360 would be the full revolution. 135 is only part of that. So we need to figure out how much is that? How much is 135 out of 360? And if you type that into the calculator, that is step number 2. You find that 135 out of 360 is equal to 0.375. So that means this right here, this angle, is 37.5% of a full revolution. So if we take that 37.5% of a full revolution, what we can do is we could say that our arc length is only going to be 37.5% of the full circumference. So that's why we're multiplying these two things together. And that will give us this number right here, 14.1 feet. That is our arc length. Go on now to the next problem. Okay, arc length of FJH. Now here in a second, we're going to need to figure out some stuff with angles, but let's start with step number 1, okay? This is the ultimately what we're going to try and end up with is the length of this blue highlighted area right here. But here's what we're going to start with. Remember your 3 steps. Step number 1, number 2, and number 3. I'm going to copy and paste those onto this slide too, just to make sure we've got it. Step 1, find the circumference. So we take our formula, 2 times pi times the radius. You can see right here that the radius is 3. So we've got 2 times pi times 3. Our radius is 6 pi. Or if you're using a decimal approximation, you could say that it's 18.85 meters. That's your circumference. Now, let's talk about this next part. If we're trying to figure out the central angle fraction, we need to know what our central angle is. Okay, what is the angle that is connected to this arc? What is that angle that I just marked off right there? Okay, so we need to think about what we know about circles already. If you start right here and you rotate all the way around one full revolution, that's 360 degrees. We all know that already. Well, we can see that right here, if we only went through this much of it, that's already marked. That's 90 degrees. If we started right there and went over to this line, that would be 80 more degrees. So the total of this right here is 170 degrees. We know that the total thing in one full rotation is 360. So if we're looking for this missing piece, and we know that this much of it is 90, this much of it is 80, and we're looking for what is missing, wouldn't it make sense that we could just subtract 360 minus the two angles that we know? That right there would give us the total of our angle, the one that I marked off right here, 190 degrees. That would be this angle right here is represented 190 degrees. So step number 2, finding your central angle fraction, is this piece of it right here. This piece of the formula, 190 out of 360, gives us 0.5278 approximately. And if we multiply our circumference times that fraction of the angle is going to be the same fraction of our circumference. So if we multiply that fraction times the circumference, it gives us the length of just this part of the circle. Just that arc is going to be 9.95 meters. Up next, we've put it in terms that I can understand very easily, putting it in terms of my absolute favorite food, pizza. A pizza with a diameter of 16 inches is cut into 6 equal slices. Before we go on any further, I would like to address the fact that a 16-inch pizza only cut into 6 pieces is a huge amount of pizza per slice, and I am absolutely here for that. Okay, so that's beside the point. Um, what we are interested here in is finding following our 3 steps: find the circumference, find the central angle fraction, and multiply those two numbers together. Okay, so the circumference, this one ends up being pretty easy because it already gave us the diameter, and we know that the circumference is just pi times the diameter. So you can take that pi, multiply it times this 16 that it gave us. That will give us our circumference. It's about 50.265. Okay, that's rounding it off, but that's pretty good. That's pretty close approximation right there. There's your circumference. Now, here's the question. When you talk about your central angle fraction, what we've always done before is we figured out what that angle was and divided by 360. Y'all, this fraction, the central angle fraction, has already been given to us in the problem. It says that this was cut into 6 equal pieces, and we are looking for the length, the arc length, the crust length of one piece, one out of those 6 pieces. That is the central angle fraction. Okay, whatever if you split up 360 into 6 equal parts, that would be 60 degrees. Well, 60 out of 360 is 1/6. We already know that. Okay, we didn't have to do all of that work putting 60 divided by 360. We did not have to do all that because it already told us that it was split into 6 equal pieces, and it told us that if that is the case, we're only looking for one slice, then that would be our fraction right there. Okay, so all we got to do is multiply the circumference times 1/6. All of these pieces of crust are going to be the equal size. It's been split into 6 equal size pieces, so it's easy. You just take that and multiply times 1/6, and that gives us a crust size of 8.4 inches. Okay, once again, I just want to point out that if your crust is 8 inches across right there, and it's 8 inches down to the point of that pizza, that is a huge slice, and I love everything about that. Okay, so we are not going to do this last problem. This last problem right here, we're not going to bother with it. But what I do want you to do is make sure that you've got all your Canvas problems done. All of them are going to be due on the same day. And there will be an announcement posted about this also. Okay, all of them are going to be due very soon. All of them are going to close not very long after that. So make sure you have finished up all of your Canvas work up to this point. And that is all we've got for this section of notes. So y'all have a good day.